Hello guys, I am Nidhi Pagalwadi, your science teacher, Sankalp Learning Solution. In the last class, we started the ionic compounds, right? And we started how the formation of ionic compounds takes place. And we discussed two examples like sodium chloride as well as magnesium chloride. So today by analyzing those examples, today we are going to define the definition of ionic compounds. So as you can see on the board, the ionic compounds are nothing but these are the compounds formed by oppositely charged ions like anions and cations. How the ions are formed? That is by losing electrons as well as by gaining electrons. And from the examples we got to know that usually the metals have a capacity or have a tendency to lose the electron, while the non-metals have a tendency to gain or to get the electrons. So today we are going to discuss a lot more about ionic compounds and their properties. In an exam, they will ask about the formation of ionic compounds as well as the dot structure. Suppose if they told you or if they ask you to write the question like write the dot structure, write the dot structure of sodium, comma calcium. Okay, so sodium, when you take its electronic configuration is 2 comma 8 comma 1. So the outermost shell has one electron. So the dot structure will be Na1. Similarly, calcium. So when we see the electronic configuration of the calcium, so it is around 20. Okay, so the atomic number is 20, 2, 8, comma, 2, 10, 10, comma, 8, 8 plus 2, 10, 10, 18, 2, 8, comma, okay, 2. So here it is 2. So calcium I can write it as 2. Like this we have to write the dot structure. And sometimes they will ask the formation of ionic compound. Write the formation of. So let us take the second example like write the formation of Na2O, that is sodium oxide. Fine. So here sodium is a metal, oxygen is a metal. Here it is compulsory to know, it is very important to know the electronic configuration as well as atomic number of these substances like metals and non-metals. Okay. So you should learn the atomic number from the periodic table. Now, so here the first step is step 1. Sodium electronic configuration 2, 8, 1. And similarly, oxygen electronic configuration 2, 8. Uh, yeah, 2, I think 6. Its atomic number is 8. Sodium atomic number is 11. 2, 6. So here, as you know that sodium want to lose one electron to get octet electronic configuration. Octet means last shell should have 8 electrons. Okay. Then oxygen should need 2 electrons to get octet electronic configuration. So it needs 2 electron. It wants to lose 1 electron. But as they want to make a friendship, sodium has only 1 electron. But oxygen is need of 1 more electron. 2 electrons it needs, right? So that is why we are going to consider 2 atoms of sodium here. That is why it is Na2. 2 atoms of sodium. So let us write the reaction step 2. So sodium want to lose 2 electron. So 2 electrons are lost means like this 2 electron. So as it loses 2 electrons, protons will be same. So 2 plus protons will be 2 1 1 2 means here the protons will be same. That is why A10 in case of one sodium atom, the 10 in case of other sodium atom. That is why 2 plus. Next, oxygen want 2 electrons. So oxygen plus 2, as the negative charge increases, so it gains negative, we can say negative sign. So oxygen, don't put this one circle, O minus. So this is step 2. And next one is step 3, that is transformation of transferring of electrons. So Na has 2 electrons, 2 Na we should write, otherwise we can write like this, Na, 1 and 1, plus oxygen. So it has how many electrons in its outermost shell? Oxygen has, where it is, yeah, 6 electrons, 6. Okay, now the transfer of electrons should be done. So one electron from this, one electron from this. So here what happens is Na2O is formed by 2, 3, 4, 5, 6, 7, 8. Right? So here, this is how the formation of sodium oxide takes place. Like this, we have to write the formation of ionic compounds when they ask for an exam. So they may give magnesium oxide, they may give calcium oxide, anything they might give. So you should be knowing the atomic number and the electronic configuration. So then only you can write the dot structure, then only you can proceed with the reactions. Okay. Now, let us study the properties of ionic compounds. So, ionic compounds. What are the properties of ionic compounds? We got to know the definition. Properties means what? Means how they look, how they react. That all we are going to learn. For that, we have to perform certain activity. For example, first we have to take all the ionic compounds like magnesium chloride, sodium chloride and all. Then we have to heat it. Then we should see their physical appearance. Then we have to pass the electricity through the aqueous solution. So after these all activities, we will come to the summary of the characteristics of the ionic compounds, or we can say properties of ionic compounds. So the ionic compounds salts, we are going to see it, visualize it in the next session. Okay. So let us discuss properties of ionic compounds now. Properties of ionic compounds. Fine. The first one is physical nature, means how they are. Physical nature. For example, let us take a sodium chloride, which we can observe or we will use daily. Sodium chloride is nothing but a common salt. So how is it? It will be crystalline, it will be solid, and whenever you apply pressure, it will become powder. Right? So here we can say physical nature of ionic compounds will be solids, and we can say they are brittle, means they will become powder on applying pressure. On applying pressure. Next one, when we heat these ionic compounds, so when we get to know or when we measure melting point and boiling points, melting point and boiling point. Okay, as we know that these ionic compounds are nothing but the aggregation of the oppositely charged particles. So here in between the charged particles, we will be having the force, the inter-ionic force. Inter means in between, ions, force, in between ionic force. So that inter-ionic force will be very strong. They will not, the molecules or that ion will not break very easily. So when that ion will not break easily, means we should provide more heat, we should melt more. So due to strong inter-ionic force, they will be having highest melting point and boiling point. So due to, we can say due to strong inter-ionic force, okay, they have high melting point and boiling point. Okay, high melting point and boiling point. Next, so when we add these salts to the solvents like water, kerosene, petrol, so we will come to know that almost all these salts are soluble in water. They are not soluble in organic solvents like kerosene, petrol and all. So we can see that solubility, soluble in water, soluble in water, but insoluble in organic solvents. Organic solvent means they will be having more carbon, like kerosene. They are the carbon compounds, kerosene, petrol, etc. Okay, so solubility. Next one is conduction of electricity. Conduction of electricity. So here, as you all know, the ionic compounds are made up of ions. Ions are nothing but the charged particles, right? Ions are nothing but the charged particles. So what is electric current? It is nothing but the flow of charged particles is called as electric current. So these what we can say ionic compounds conduct electricity when they are dissolved in a water. Why? Because when they dissolve in a water, they will break into ions. Otherwise, they will be in the form of a compound. They will be attached through electrostatic force. So suppose uh, water, if you take, you add NaCl, and if you dip any electrodes and connect it to a battery, so that time they will conduct electricity, because the electric current which is passed from a battery breaks up them into ions, individual ions. When then the ions are produced, they start moving, which gives out current. So here they will conduct the electricity in the solution when they are in the form of a solution, as well as when they are in the form of a molten state. When the salts are in molten state. Molten state means what? The molten state means we will heat it to get melt. Na? So that heat provided, okay, will be strong enough. Will be strong enough means it will be okay, or it is sufficient. The heat will be sufficient to break inter-ionic force. To break inter-ionic force. So when this inter-ionic bond or a force will break, then we get again the charged particles which can move freely. So that free move or free flow of charged particles produces electric current. So by this we can say that the what we can say, the ionic compounds conduct electricity. They will conduct electricity only in the solution form as well as in a molten form. You can ask me why they will not conduct electricity in a solid form. In a solid form, so we know that they will be solid in a form of a crystals, right? So in the crystals, the ions are not free. They will be in the form of a aggregation of oppositely charged particles. They are not free. When they are not free, they cannot move. In the solid form, they will be having strong inter-ionic force. In solid form, they have strong inter-ionic force. So due to strong inter-ionic force, the charged particles cannot break. The ionic compound will not break. Then the charged particles will not move. When there is no movement of charged particles, when there is no flow of charged particles, then there is no current. So in the solid form, they will not conduct electricity. Fine. So in the conduction of electric current point, we can write that fourth point, conduction of electric current. Okay. So in conduction of electric current, the ionic compounds conduct conduct electricity in a solution, in the solution. Next point, the ionic compounds conduct electricity conduct electric current in molten form why? As heat supplied overcomes, means it will be more than the ionic, sorry, you should write interionic force. Last point, in solid form they will not conduct electricity, they will not conduct electric current due to, why? Due to strong interionic force. Strong interionic force. So this is regarding conduction of electric current through the ionic compounds. So today we learned the definition as well as properties of ionic compounds. In the properties of ionic compounds, we learned physical nature, we learned regarding melting and boiling points, as solubility, as well as the conduction of electric current. Okay. In the upcoming session, we are going to learn regarding the metallurgy concept. What is metallurgy? As we learned a lot more about the chemical reactions of metals and non-metals, it is very necessary to know from where do we will get the metals from how do we will get the metals. So metals are taken from the earth crust, through some procedure, through some processes. So the process of extracting means the taking out of the metals from the earth crust is not same for all the metals. Means iron will be extracted in some other method, magnesium will be extracted in some other method, or by following some other steps. So that extraction of metals and the steps and the processes we are going to learn in the next class. So the extraction of the metals will also dependent on the reactivity of the metals. The most reactive metals will be extracted in by some steps, certain steps, and the middle or the moderate reactive metals will be extracted by some other ways. So which are the ways, which are the processes, we will learn in the next session. Until that, take care, have a nice day, bye bye.